part 2 of biofilms and periodontal infection. So now we're going to talk about how the bacteria colonizes on the tooth. So, co-aggregation of bacteria. Basically, the building up and massing of bacteria. Cell-to-cell adherence of one oral bacterium to another. Not random, it's very specific. It has a limited set. Each bacteria strain only has a limited set of bacteria they can adhere to. Co-aggregation is the ability to adhere and co-aggregate, and it's important in the development of how biofilm bacteria colonizes. So, here's the picture of co-aggregation. This is different than the gram stains that we were talking about. But we see that Fusobacterium nucleatum, or the friendly bacteria that has lots of friends, is the bacteria that is both good and bad, and it invites the bad bacteria to colonize later, and those are the first disease producers. So let me review that again real quick. You have, gram-positive bacteria that lies first, right? And you have different types of bacteria. But the Fusobacterium nucleatum is the first disease producer because it's the one that the bad bacteria starts to come and associate with first. Excuse me. Sequence of colonization. Alright, early colonizers. Early colonizers are the first bacteria to colonize, and they're not bad, they're non-pathogenic. Early colonizers lay the foundation for the growth of biofilm. Important because it's really big. Periodontal pathogens are unable to colonize the biofilm until the non-pathogenic species are attached. So, like we talked about in class, periodontal pathogens, or the bad friends, aren't able to go to the party on the tooth until they find out when the party is and get their friendly friends to open the door for them, or the Fusobacterium nucleatum, right? So you need to have non-pathogenic species or early colonizers on the tooth first before you can have periodontal pathogens attach. So early colonizers are predominantly round, and they're gram-positive, which means they're good. Let's see here. So like I talked about before, bad bacteria or periodontal pathogens just kind of free float in the oral environment. They're waiting to be attached to the tooth by Fusobacteriatum. Okay? Alright. Streptococcal species. These are early colonizers. So we talked about early colonizers in general. Now we're talking about specific names of bacteria that are early colonizers. Streptococcal species have the ability to attach to the tooth pellicle, because remember, they're early colonizers, so they're the first type to attach to the tooth. And other early colonizers cannot attach, but have the ability to go aggregate with streptococcal. So, streptococcal species are the people throwing the party, right? It's at their house, parents are gone, out of town. It's this streptococcal species is where the party's at, right? Now, you can have other early colonizers show up to the party, friends of streptococcal species, but it's not their houses, it's streptococcal's houses. Does that make sense? So, streptococcal species are the first colonizers on the tooth. Alright, and now you have intermediate and late colonizers. So, like the early colonizers, intermediate and late colonizers must join the biofilm in the proper sequence. Intermediate and late colonizers can't throw their own party. Remember, because the only people throwing a party on the tooth is streptococcal people, or pathogens. So, not pathogens, I'm sorry, streptococcal bacteria. All right. So let's kind of summarize that idea together. You have free-floating bad bacteria in the mouth, which cannot cause disease because it's not attached to anything yet. It's just free-floating in the mouth. Periodontal pathogens cannot colonize the biofilm until the non-pathogenic early colonizers attach first or throw a party. You can't have the bad bacteria show up at the party until you have a party, right? So, if you disrupt biofilm daily by good oral hygiene and self-care, the biofilm will always be reforming. So basically, every time you disrupt biofilm in your mouth, the process must start all over again. It's like the police breaking up the party before the bad bacteria gets there. The Streptococcal family has to throw another party, invite some other early colonizers who invite Fusobacterium bacterium or whatever, nucleatum, Fusobacterium nucleatum, who invite the bad bacteria, right? Okay. Now let's talk about stages of bacterial colonization. So, kind of reviewing what we talked about, you have colonization of the pellicle, which is early gram-positive bacteria. This can be Actinomyces and Streptococcus. Those are the early colonizers, the ones who throw the party, okay? And then you have intermediate coaggregation, which is when they start to multiply. So you have Streptococcal family who's throwing the party, who's bringing more streptococcal friends and other early colonizers. And then you have gram-negative bacteria join. And the first gram-negative bacteria would be Fusobacterium nucleatum, because remember, that's a friendly middleman bacteria. You can also have Prevotella intermedia, and that is a kind of a middleman bacteria as well. All right, and then you have the bad organisms show up, right? Because they were invited by their friendly friends. So gram-negative bacteria starts to colonize. This is P. gingivalis, Captonocyphaga gingivalis. And they start to show up. So, Sokransky's microbial complexes. Don't know what this is, but we will learn. Internal organization of bacteria. So, organization of bacteria within a biofilm is not random. A specific association among bacterial species exists. Bacteria organize themselves smart. So basically, Sokransky's microbial complex is a way to organize bacteria by colors to figure out what they do instead of identifying each and every bacteria on its own. Okay? So Sokransky's complex colors, basically it's grouped microorganisms assigned to a color. The colors are based on association with health or disease. So, yellow and green complexes are early colonizers and are believed to be compatible with gingival health. That makes sense. Green means go, green means good, right? Yellow is kind of good too. So yellow and green are good colonizers, or are colors that are associated with good colonizers or early colonizers seen in health. And then you have orange and red. These are complexes that are thought to be etiologic agents of perio disease. So bad color groups of pathogens. Now remember, Sokransky's complexes, they're not having to do with gram staining. We're not talking about staining the bacteria. We're talking about grouping them in groups and naming those groups colors. Does that make sense? So, like for example, the yellow and green ones are good. So you have Streptococcal family and a bunch of others. And then red and orange are bad. Excuse me. All right. So, bacterial attachment zones and mechanisms of periodontal destruction. Dental biofilm development always begins supragingivally, and then moves down sub. So in the mouth, at 0 hours, you have acquired pellicle. And then within hours, after that, you have early colonizers, right? And they attach supragingivally, or above the gum line. And then after about 6 hours, the surface of the crown of the tooth becomes covered with plaque, supragingival plaque. And this is the streptococcal family. And then at the 7th day of haviness, you have plaque maturation, which is when actual mature suprabiofilm forms. And 3 to 12 weeks after that, you have subgingival biofilm that forms. So that's the sequence of how biofilm attaches. Current research shows the body's immune response to biofilm is the primary cause of the destruction seen. Again, we know this. It's not the bacteria that affects the destruction of your mouth. It's the way your body's immune system responds to it. So biofilm is a necessary part of perio, but it's not the causative factor. It's how your body responds to the biofilm that's causing the factor. So just to review, who are the primary tissue destroyers? TNF, tumor necrosis factor, PG, prostaglandins, and they destroy alveolar bone, and MMPs, or matrix metallopreenas, which destroy connective tissue. These three are elevated in numbers in chronic inflammation. Biofilms. Biofilms are found throughout the oral cavity. Not all people have bacteria found in biofilm. So again, this proves our theory that perio isn't caused by biofilm. It's caused by the individual's host response. So again, that's why physical removal of biofilm is essential. Controlling the bacteria in your mouth is controlled by controlling the biofilm. Brushing, flossing, professional instrumentation. And that is part 2.